So number 10, finding velocity. These questions get a little bit more complicated, but it's the same thing. We're just, instead of finding average acceleration, it's set up differently. So we have to mess with the equation, do some dividing, and so multiply time on both sides. I mean, you know. All right, so a car's acceleration at a rate of accelerates at a rate of 12 meters per second squared for 6 seconds. What's the change in velocity of this car? So we know it accelerates at a rate of 12 meters per second squared. So acceleration here will be 12 meters per second squared. And it's doing that for the change in time will be 6 seconds. Cool. We don't know our velocity yet, the change in velocity, but we'll find that out. So let's plug what we know into our equation here. So, line, I have my average acceleration is 12, right? So 12 meters per second squared equals, and I know my velocity is unknown. I know it's unknown. I know that. And then my change in time is 6 seconds. Cool. So now we'll bring this whole situation over here and then go to the next step, which is multiply time on both sides. So that's 6 seconds. So we'll rewrite everything we have. So we've got 12 meters per second, right? Equals the change in velocity over 6 seconds. And I know I have to multiply time on both sides, so I'm going to do this in a different color. You don't have to, though. So times 6 seconds on one side, and times 6 seconds on the other side. Cool, so the next step here, okay, after I multiply time on both sides, the 6 seconds, we brought that up so we can get velocity by itself. We can cancel that out. So the next step here, and I'm gonna rewrite everything here just for this first problem, down right beneath it, and then we'll cancel it out. So we'll see what we have left. So we have 6 seconds times 12 meters per second squared, it should be squared, equals the change in velocity divided by 6 seconds. Okay, and then we multiplied 6 seconds on this side too. And you know what happens here. You already know that the 6 seconds cancels out on both sides. Okay, right here, the top and the bottom. And then over here, we need to start multiplying these together, right? You need to combine these terms. So 6 seconds times 12 meters per second. Actually, I'm gonna keep everything I have here and I'm gonna write it here. This should not say divide, by the way. This should say multiply. Okay. So 6 seconds times 12 meters per second. 6 seconds times 12 meters per second squared, right? Equals, and all that's left here, this is beautiful, is just the change in velocity. Okay? Now this is an easy problem now. We just have to combine these terms, so 6 times 12. So 6 times 12 will give me, let's see, 16. Okay, so 72. Okay, and then I've got this 6 seconds and then 12 meters per second squared. Okay, now what's actually going to happen here is we're going to cancel out this second and one of these seconds, because this is on the top of a fraction and this is on the bottom of a fraction, right? You're looking at seconds, and we could just say that this is 6 seconds over 1, and this is meters over seconds. So the seconds are on the top here and the bottom here. We'll combine these fractions, and I'll show you really quick what that's going to look like. So 72, and our units will be in meters times seconds, right? I'm combining the seconds in these meters, divided by seconds squared, okay? And then because there's a seconds on the top and the bottom, we'll cancel those out, okay? What we're left with is 72 meters per second. And we're looking for a change in velocity. Now we have meters per second. Perfect. Okay, so let's write our full answer with units over here. So I've got change in velocity equals 72 meters per second. That's it.